Hi everyone, welcome back to part 2. In the previous video, we went through a quick planning session of how we will design the bill splitter. So we created a simple schematic, and over here we are making a few assumptions. The first assumption is that we'll be having a Telegram chatbot as a front end, and we will not be designing the Telegram. We will not be creating a Telegram chatbot, but we are able to role play, and we have decided to go with this data schema. So how it will work is that the Telegram chatbot would send us a list of items. So in this case, this is a list of items where we only have one, and this is an item called cola. Each of its price is $2, and we have 10 of them. And in this case, we have the users in this payload as well. And in this case, we have one person who's paying for that, and that is Boban. So to recap, we went through some simple assumptions too. To keep this project simple, we'll be assuming that all items have distinct names, and they also have distinct names for users. So in production, you will likely have users with different names, so it's more customary to give an ID for each of these items and users. But because our objective for this exercise is to focus more on the Springboot framework, we dumb down the design a little bit, and we are going to use the name as the primary key for the items and the users. So the Telegram chatbot will send us this payload, and we are going to be returning back the payload like this. It will contain a list of users where every single user over here contains a name attribute, a total that represents the total amount that this person will be paying for, as well as an items field over here, which itself can be sort of like a working for how we arrived at $20 over here, payable by Boban. So inside this items array, as you can see, it contains the items that Boban is contributing to. So it has the name, the price, the quantity, as well as the people that he or she is sharing the payment with. So that's pretty much the essence of the responsibility of our backend. So for our backend, we'll be using the Maven architecture for this. So we have the model, view, and controller. In this case, to recap, for our parrots out there, the controller layer is responsible for controlling which exact view is a client going to see when they send a request. So for this project, we only have one view. To be specific, we would have one route, and this route, localhost/split view, they will send us the input, and we would hit only one view inside our view layer. So this view layer over here is, to be specific, the view represents the data that will be returned back to the user. So this view over here would only have one service. This service is called the bill splitter service, and it takes in a list of items and a list of users. And you'll be making an assumption that these items that are provided will be split, like the prices of these items will be split evenly across all these users over here. So of course, because we are dealing with data, it also makes sense for us to define the data models on the model layer as well. So to recap, we have two input models. The first model represents the input item, and it's specifically referring to this dictionary over here. The second input model is the input user, and you can see that it refers to this user over here in the input. On top of these two data models, we also have three output models. So the first one is the output user, and the output user over here is the high-level data class for this dictionary over here. So this output user has a name attribute representing the name of the user who is going to pay something, and a total field of type double that represents the total amount of money that Boban is going to pay for. And finally, it also contains the items, the output item here, just below here, that represents the items that Boban is contributing for. So the second output model is the output item nested under output user. It contains a name attribute representing the name of the item, the price of each unit of item, the quantity that we have, as well as the people who Boban is splitting this output item with. And for this, in this case, the people, this is a slim user data class, and the slim user data class is our final output model, our third one. So that's pretty much it. So now that we have a high-level overview of what we want and we understand the prompt statement, let's try building this from scratch, starting from the controller layer. So the fortunate thing is, for all Spring Boot applications, there's usually some form of pattern regardless of the business use case. Like the way we define the controller and the view is very similar with respect to the documentation, as I would like to believe, as compared to other frameworks such as Flask and Play as well. So with that, let's get started, and let's start off from the documentation. So, okay, you build a classic hello world endpoint which any browser can connect to, and you can tell your name and respond in a more friendly way. Interesting. So this quick start guide will guide us towards that, a very simple application. And I guess that's a good start. We will try creating one that just says hello world, and we will start adding in more parts to this so that we can get a build splitter. So we need an integrated developer environment, fancy word for code editor, and we have IntelliJ open over here. So before this video, I took the opportunity to set up a project, but this should be quite trivial, so I will leave it to you to read the IntelliJ documentation to start off with a new project and choose which framework you want. I mean, do you want to, depends on what build tool you're using. In this case, I have went ahead and chose Maven, a project template from Maven, but to be frank, okay, I guess we do need some dependencies here because we are downloading the Spring Boot framework. So yes, a simple build tool to manage your dependencies would be helpful. So I would recommend Maven. We also need our Java development kit, so I'll leave it to you to download that as well. So now let's go to, so they're recommending that we go to Start Spring to create a web project. In the dependencies dialog, search for add web dependency as shown in the screenshot and hit generate button. Okay, let's go here first. And okay, we have Start Spring here. So in the dependency dialog, search for and add the web dependency as shown in the screenshot. So we have to click Maven project. Oh, okay, I guess I was supposed to set it up here. So the project setup that I clicked on IntelliJ earlier is not really necessary. But okay, we're using Java 17. I'll go ahead with Java 17. Let's see. Actually, let's just go for Java 11. Yeah, let's use that. I guess the documentation was released when it was 2.2.6 and now it's currently 3.0.2, but it should be fine for us to use the latest version. Let's call this com.buildsplitter, and let's call this buildsplitter com.project I don't know, tutorial, com.tutorial.buildsplitter. So this is the prefix alias for our package name, and the artifact in this case represents the final part, the postfix of our package name. So I guess that's it. And now let's click add dependencies and type web in the search box. So let's click this, let's type in web, Spring Web. So build web, including RESTful applications using Spring's model view controller, uses Apache Tomcat as the default embedded container. Okay, sounds great. Okay, and now I guess thanks to this quick start, they're going to set up the boilerplate for us. So it's really amazing that our the open source developers have so kindly done this. So I'll be opening up this zip file in a bit and we will continue the recording from there. Hey, welcome back. So what we did is we extracted out the zip which we downloaded from the boilerplate web app just now, and this is what we have. We have a POM file, and this POM file represents the dependencies that this project would have. And as you might guess, because we use the Spring framework, we would also have to download all of the code that is responsible for the framework. So thanks to the boilerplate generator, they have configured our POM file to include Springboot as a dependency, and they specified the version for us as well. So thanks to the boilerplate generator, it seems that we don't have to handle this ourselves. So the next part is to take a look at what we have. So all of these files that you see over here are all generated by the boilerplate. And as you might see, like the entry point for this current project is this class over here. So this class is given an annotation, Springboot application, and from what I understand, Java annotations adds in additional information about this class at compile time. But that said, from my experience, I noticed Spring frameworks, they have these annotations and they are really nice, but there's some magic going on, and it seems that these annotations are not just meant for adding information at compile time. It seems to tell the Spring framework like exactly how this is going to be, like what exactly is the behavior of this class over here. So I guess if you are to annotate this class with this annotation over here, then this tells the Spring framework that this class over here is really the overarching application, and this is the entry point. So we also have a main method over here, and it seems that we are calling the run method, like the static method from Spring application, and it seems to take in a class which is, I guess, this application, and pass in some arguments. In short, this line over here is really spinning up the application. So to validate my hypothesis that this is a static method, I'm going to put my cursor here and press Command B, and this allows me to introspect the implementation of run. So sure enough, it is a static method, and it seems to return back a configurable application context. Okay, it looks pretty cryptic, but this is a class file. So looks like this configurable application context is an interface, and it implements even more, it extends even more interfaces. So that's a lot of details, but my favorite way to go about this when we encounter a very broad, or rather like a pile of information, I would love to prioritize only the things that we need. So for now, despite us having limited information on exactly what this configurable application context is, from its name, you can kind of guess that context is like a group of information, you know, like context. Can you tell me the context about something? In this case, this application context contains some additional information that Spring Boot needs to understand the so-called the state of the application. So that's my hypothesis, but I guess that's a pretty good guess for now. So I'll just accept the fact that this is our current entry point to the Spring Boot application, and we are currently spinning up the application on line 10. So that's it. That's all we need to know for now, I guess. Let's go back to the documentation. So at this point, we have opened up the project on IDE and located the entry file inside our folder. It's a little bit different from the tutorial, but we get the gist. Now we have to change the components of the file by adding an extra method, this extra method over here, and the annotation here, the REST controller. So as you might guess, by adding the annotation, this would let Spring Boot know that this class is not just the entry point for the application as well. It is also going to have the responsibility of being the controller. So to our parrots who are new to the model view controller framework, to recap, the controller layer is responsible for deciding what the user will see if they hit a certain route. So in this case, notice that for this function or method in this case, this hello method is annotated with this get mapping over here. And the parrots might notice, hey, what do you mean by get over here? So get here is a HTTP get method. So HTTP API requests have verbs. So get in this case is reserved for requests that are responsible for fetching information, and they are not sending any information to our service. I mean, they technically can, but get is usually used for, I guess, requests that's responsible for fetching information. So if you have to send data to, if you want to persist data in a service, you would use other verbs such as post or update or delete if you want to delete something. But in my experience, typically we use post more often, so more of get and post. So as a beginner, I would recommend just familiarizing with yourself with get and post. So over here in this method, it returns back a string. And over here inside the arguments of hello, we also have a request parameter annotation as well. So it seems that we are taking in a name field, and the default value is going to be world if not specified. And yeah, it takes in a string name here as well. So I guess this annotation is used to specify an input to our clients, and if they provide it, then it will be passed in under this name string variable over here. And afterwards, what we did is we just format it and we return it here. Yep. So looks like we will be returning this back to the user. So let's quickly add in this annotation as well. Okay. So looks like we need to import it. Let's take a look. No documentation here, unfortunately. I was hoping for some doc strings to tell us exactly what this does, but I guess that's fine. We have to rely on the documentation. So let's define the hello method. So I think what I remember was public string. Is it? Yes, public string hello, and this has a get mapping annotation here, and it seems that it takes in a path. So let's call this hello like this, and over here it takes in request params, I think. Yes, request params. So request params, and over here we have to import this annotation as well, and we have to pass in value equals to name, and this value will correspond with this value over here is the name of the field. We have a default. Let's call this world, and let's define a name variable over here. So looks like it's complaining about something. Oh, default value. It should be default value. Let me command B into this to see what's this. Okay, so it looks like you have the value over here represents the name of this field, and you also have a default as well. Yep, this default value over here. So okay, and this hello over here would be formatting this name. And why exactly are you hello? Oh, hello. Okay, so you want to say hello, and you would pass in the name like this. So why is this complaining? Yes, because this method is supposed to return back a string. So I forgot about the return keyword, so that's why it's complaining. So now we have done the two steps that the tutorial has recommended. First, adding in the annotation REST controller so that Springboot knows that this application has the responsibility of the controller as well. It will dictate what view the user will see. And we created a simple view function. I guess I'll call this the view function. And this view over here is exactly what the user will see if the users send a request to us with hello. So looks like that's all. And over here in the documentation, they explain it further. Takes in a string parameter called name, combine this with parameters with hello in the code. That means if you set your name to Amy, the response will be hello Amy. The REST controller annotation tells Spring that this code describes an endpoint that should be made available over the web. And the get annotation tells Spring to use a hello method to answer requests that get sent. So did we do that? Yes, we did. So finally, the request param annotation is telling Spring to expect a name value in the request, but if it's not there, you'll use the word by default. they mean world, I guess. Yes, that's a typo. So let's build and run the program. I guess that's all the changes we need. Open the command line terminal, navigate to the folder where you have the project file. We can build and run the application by issuing the following command: gradle w springboot run. Okay, I guess we're using Mac, so let's copy this and let's run this. Oh, I need a gradle file. Okay. But I do have a gradle here, I think. Okay, do I? Yeah, looks like I don't. So I have to download that, I guess. So okay, let's see how we can download this. So what's the error again? So no such file directory gradle. So download gradle w. Okay, let's install this. Okay, so the first thing is, okay, so this is a build tool. So interesting. So they are we are using Maven, so I guess it's nvn run, I guess. But how do we specify the spring key? Interesting. They gave us the instructions for using Gradle as a build tool, but we're using Maven. So how do we spin up this Springboot application using Maven instead? So spin up Springboot application using Maven. So okay, we have done this. Let's see if there is okay. Oh yes, there it is. So if you use Maven, run the following command in the terminal window. So /nvm w springboot run. Okay, let's see if this works. Okay, let's see. I guess it's going to take some time to spin up the application. Okay, let me just do this again to be sure that it's not hanging. Okay, I guess it takes some time. That's way longer than I expected. I would expect this to spin up in like right now or something. But okay, let's take a look at this documentation in the meantime. Yes, so we initiated the boilerplate using the Spring initializer like we did over here. Seems like this tutorial is pretty good. But they have a bean as well. Okay. Okay, I guess hopefully it should be done by now. Oh, it's still, oh my goodness, it's still running. Okay, I guess we will come back after this application starts. I'm not too sure if it's hanging because of me or my current setup or something, but let's see. After this starts, we will come back to this. Okay, after doing some more Googling and having a lot of trust issues with the documentation, I realized that it wasn't clear, right? When we ran the command earlier, which was this command here, it just hanged. So I was like, wow, like usually when you spin up an application, it will usually log something so that it tells you exactly which port we are hosting the server on, and just tells us something that something's starting up. So apparently this command didn't work out well, so I did some more Googling, and we were lucky to realize that there's another recommended command. So there was nvm springboot run. So we tried that, and turns out that it did work. So let's try this, and nvm springboot run, and as you can see, it starts up. So that's actually the command. So we can see that it's up at the moment, and it's being hosted at port 8080. So now that we get the server up, let's try sending some data to it. So we'll be hitting HTTP at localhost at port 8080, the same port number that our application is being hosted on, and we will pass in hello as the route. And to our parents who are thinking, why hello? If you look under the application, we can see that we have annotated this method hello with this route over here. So what this means is that the controller would route all requests to this application to hit this method over here. And this method's response would be given back to our client. So our hypothesis is that if a user comes in and hits localhost 8080 at route hello, then the client should receive back hello followed by the name that the user provides. So what I'm going to do is I'm going to open up Insomnia. Insomnia is a simple client tester, so you're able to make requests to your server using this very nifty tool. So what we have over here is we are making a GET request to localhost at port 8080 and at the same route that we have provided to get mapping annotation. So the next thing is we're going to change this to multi-part form, and let's try sending a request without any inputs. So now we send something and we can see that we get hello world. That's because if we take a look at this method over here, the default value is world over here. So if we do not provide something, then the name to hello would be default to world. So now let's try passing in our own arguments. We are setting a multi-part form, and now if we send this, we can see that the server responds back with hello Bowen. So yeah, it seems that in this part we are able to get the server up and running, and yeah, we have effectively created a simple class that is serving as the controller, and we have this as the view. We don't have any data models at the moment because we are just returning back hello world or hello name. So but for this this second part of this video, I guess it's a good demo for how we are able to generate a simple boilerplate with the help of Spring Initializer. And we see how the Spring Initializer was really kind to set up our POM file for us so that we have all the dependencies we need to spin up this Spring Boot application. We then see how in the boilerplate we were given a nice class annotated with the Spring Boot application, and this tells Spring Boot that this is the entry point of our application. We then proceeded to go through the documentation, and we were able to edit this code to annotate this existing class as our controller as well. Is this great? I personally would not like having one class with two responsibilities. Now it's like the application and the controller and containing the view methods as well. So it's like having the controller and the views in one layer. Not very nice, but it does the job for now. So we also got comfortable with the get mapping annotation. This tells Spring Boot that, hey, controller, if you see any request that comes in with hello as the route, then call this method over here. And this method over here, you can think of it as the view, the data that the user sees if they hit this route over here. And we saw how we could define our own inputs that we expect from the user. So we define a name parameter and we annotated it with the request param annotation so that Spring knows that we want this as an input from the user. And yeah, and we were able to define defaults as well, and we return this back to the user. So yeah, that's pretty much it for the second part of this video. I hope this was a pretty good demonstration of how we can easily come up with a Spring application with just a few lines of code. So in the third part after this video, we'll be building on top of this. We'll be building our own custom view layer, and we will be defining the build splitter behavior. On top of that, we will also start defining our data models, and we will wrap up this project. So with that, thank you so much, and we will see you in the next video.